Hello everyone and welcome to this lesson on cumulative frequency. I hope you're all well. In your exercise books, can you pop cumulative frequency as a title and underline it and be ready to have a go at this do now task. If you can pause the video while you have a read through and then start playing again when you want to go through the answers. So the do now task then gives you the salaries of 11 people working at a firm. It asks how could we work out the average salary and what is the disadvantage and advantage of each approach. So the salaries are given in thousands. So the first salary of 24 is £24,000. So if we were wanting to work out the average salary, so we're going for the mean and the median. Just want to say a big shout out to Dr. Frost as I've used quite a few of his slides within this PowerPoint. Also I've got a link to a Corbett Maths video, so just needed to make you aware of that. Back to the question then. So to find the mean, you should have added all of the 11 salaries together and divided by 11. If you use this video without the walkthrough, so if you use the PowerPoint that's within this week's work, you will be able to click on any of the question marks to reveal the answers throughout. So the mean salary is £49,182. The advantage for this is this average takes all of the values into account. The disadvantage then is this is not very representative of the typical worker. As you can see, only 2 of the workers have a higher salary than the average of £49,182. The median then is another way of working out the average salary. So this is where we're finding the middle value when the values are in size order. So they're in size order already for us. So crossing off into the middle, the median value would be the £29,000. The advantage of this is it's more reflective of a typical worker's wage. The disadvantage to this being that it ignores all the values other than the central one. For part B, it asked us how could we numerically describe how spread out the salaries are and how useful is the value that we have. So a good measure of spread is the width of the data, so i.e. the difference between the smallest and the largest value, we know is called the range. So the range of the salaries is £192,000 subtract £24,000, which gives us £168,000. The more spread out the data is, the greater this range will be, and we can see this range of the salaries is quite high. This range of £168,000 doesn't effectively represent how spread out the data is, because if you look at the salaries, they don't actually vary by very much. So how can we combat this? So another measure of spread we can use, and we will look at this shortly, is something called the interquartile range. There are also Hegarty tasks set for you this week on finding what are called the upper and lower quartiles, which we go through during the video, and also the interquartile range. Anyway, the interquartile range works out the width of the middle 50% of the data. So we get rid of any outlying data. So in this case, we work out an upper quartile, and we'll show you how to do that throughout the video, of £44,000, and we subtract from it the lower quartile, which is £25,000. So the middle 50% of the salaries vary by 19,000. This interquartile range, it allows us to ignore the extreme salaries at each end of the data, and it's a very useful measure. So our success criteria for today then, our bronze objective, we are going to be able to find the median, which hopefully you can do already, and the quartiles of the data. So this is when I'm talking about the lower quartile and the upper quartile. We are going to be able to draw a cumulative frequency graph, so we're going to go through the lesson and see how to do this, and we are also going to be able to interpret a cumulative frequency graph. When you're working through the PowerPoint alone, if you click on this video link here, this will take you to the Corbett Maths website, so you can view his video on how to draw a cumulative frequency graph for extra advice. Measures of location. Suppose that we line up everyone in the school in order of height. We already know that the median would be the middle person's height, so 50% of the people in the school would have a height less than them. The median is known as a measure of location because it gives us the value at a certain fraction or percentage of the way along the data, so in this case halfway or 50%. The height of the person that is 25% along the line is known as the lower quartile. The upper quartile is the height of the person that is 75% along the data. So let's test your understanding of what we've said so far. Pause the video if you want to have a think about this before I go through it. So 50% of the data has a value more than the median. 75% of the data has a value less than the upper quartile. 25% of the data has a value more than, again, the upper quartile, and 75% of the data has a value more than, so this would be here, the lower quartile. Determining quartiles then from listed data. Here we have the ages of 10 people at Pablo's party. It asks you to choose the correct value for each of the median, the lower quartile and the upper quartile. If you want to have a go at this before, then pause the video. Now we'll go through it. So the median value then, if we cross off from each end, as there are 10 values, as we get into the middle, we will find that we're left with 15 and 16 in the middle. Remember, when there are two values in the middle, we go halfway between. So we can see from here, it would be 15.5. If the numbers were more tricky, we could add them and divide by 2. So, choosing 15.5 then as our median. The lower quartile then. So the lower quartile, because there is an even number of pieces of data, we split the data in half. To find the lower quartile, we are finding the median of the lower end of the data, so between 12 and 15. So the lower quartile then, if we cross off from each end, we get 14 in the middle, so our lower quartile will be 14. So if there's an even number of items, we simply find the median of the first half of the data. Similarly then, the upper quartile is the median of the data values above, so the 16 to the 24. So if we find the median of those values, the upper quartile will be 17. Now the interquartile range is the upper quartile subtract the lower quartile. So in this case, 17 subtract 14, and the interquartile range is 3. So as mentioned earlier, the interquartile range is how spread out the middle 50% of the data is. The middle 50% goes from the 25% point to the 75% point. So it gets rid of any outlying ages of people that were at the party. Some quick fire quartiles then. So, rules for finding the lower quartile. If there is an even number of data items, we split the data in half and then find the median of the lower end for the lower quartile, the median of the upper end for the upper quartile. If there are an odd number of data items, so here we've got 1 to 5, we ignore the median, so we throw away the 3 and we find the median halfway between the 1 and 2 for the lower quartile and halfway between the 4 and 5 for the upper quartile. If you would like to have a go at this, pause the video and then I will go through the answers. So let's go for the medians first. So the median of 1, 2, 3, hopefully you recognise, is 2. The median for 1, 2, 3, 4 will be halfway between the 2 and 3, so the median 2.5. The median for the list, the numbers 1 to 5, well, the median will be the middle number, the third value, so that is 3. And the median for the last set of numbers is halfway between the 3 and 4, which will be 3.5. So for the lower quartile then, for an odd set of data values, we are ignoring the median, which is the 2 in the middle, and we're finding the median, well, there's only one number there, so the lower quartile has to be 1, and the median between the upper values, as there's only one value, the upper quartile has to be 3. Here, for an even set of values, we are splitting the data in the middle and finding the median of the lower two values. So that will be a lower quartile of 1.5, and the upper quartile will be the midway between 3 and 4, so 3.5. For the values 1 to 5, so we're ignoring the 3 in the middle, which is the median, and we're finding the median of the lower values, so halfway between the 1 and 2, the lower quartile will be 1.5. The upper quartile will be halfway between the 4 and 5, so we get 4.5. For the values 1 to 6, as an even number of values, we're going to split the data in half. So now we're going to find the median of the values 1, 2, 3, so the median will be 2, which will give us the lower quartile value. And then we're looking for the median of the numbers above, so our upper quartile will be 5. What about if there are a lot of items? So supposing that there are 31 items in order of value, as you can see we've got an example here. What items should we use for the median and the lower and upper quartiles? So let's go for the median first. Now if we think about this, if we had 5 data items, the median would be the third data item. So what we do is we add 1 to the number of items, so that would be 32, and then we will half that to get the median. So adding 1 to 31 is 32, half it, so we will use the 16th data item, and if you count along the list, that is the value of 17. Now we do this in the same way for the lower quartile and the upper quartile. So we add 1 to the number of items, so still 32, and the lower quartile is 25% away along the data, so a quarter of the way. So if we work out a quarter of 32, we will use the 8th data item, which is the value 6. Similarly, for the upper quartile, we're going to find 3/4 of 32, and that is the 24th item, which gives us 38. So as a bit of a tip, if you add 1 to the number of items, if there are a lot of data items, and then you find half of that for the median, a quarter of that for the lower quartile, and 3/4 for the upper quartile. This trick only works if the number of items is 1 less than a multiple of 4, but when seen in GCSE exams, this is the example that they generally go for. What item numbers should you use then? If you pause the video, you could have a go. Note that all of the number of items that we've used here is 1 less than a multiple of 4, so it makes it easier. So you're adding 1 to the number of items, then for the median, finding half, for the lower quartile, a quarter, for the upper quartile, 3/4. Let's go through then. So let's go for the median first. So adding 1 would give us 16 items, and half, the median will be found at the 8th data value. Similarly, number of items 23, add 1 on 24 and half it, will be the 12th data item, 20th data item, and 24th. So for the lower quartile, you're adding 1 on and finding a quarter. So 16 items, a quarter of that, the lower quartile will be the 4th item. For 23, the 6th, the 10th, and the 12th. For the upper quartile, again you are adding 1 on and finding 75% or 3/4 of it. So 16, a quarter will be 4, 3/4 will be the 12th item. And similarly for the others, the 18th, the 30th, and the 36th. Hegarty Clip 411 will help you with this, and that is one of your tasks for this week. Moving on to cumulative frequency then. So cumulative means a running total, and it allows us to say the count up to a particular value. So here I've got a table which gives me the number of students that own a number of certificates. So for instance, there are 9 students that have 1 certificate. There are 6 students that have 4 certificates. So how many students had up to 2 certificates? Well, up to 2 would include a student having 0, 1 or 2. So that would be the 4 plus 9 plus 7. So that would be 20 of the students. How many students had up to 3 certificates? Well, that would be the 4 plus 9 plus 7, so the 20 that we've just looked at, but also an extra 1. So I've added that 1 on to the running total, and this is how we find cumulative frequency. We accumulate the frequencies as we go along. So instead of having a number of students column, I could change this. So this is a frequency column. I can change this to a cumulative frequency. So the first value will be 4, as there were 4 students that had 0 certificates. Then how many had 0 or 1 would be the 4 plus 9, which gives us 13. How many had 0, 1 or 2? Well, that would be 4 plus 9 plus 7, which is the 20, and so on. So the 5 is the combination of all of these added together. So the cumulative frequency will always be the total number that is within your table. Looking at cumulative frequency tables for grouped data then, here we have some continuous data. So we have some people that are recorded in a table and that we're recording their heights. So here we've got a group. Remember, this means the height has got to be greater than 130 centimetres but less than or equal to 140. And there are 4 people in this category. So the cumulative frequency is 4. Now, if we think about wanting the next one being the 130 to the 150, so a height greater than 130 but less than or equal to 150, that would be 4 plus the 11. So now sometimes we can reflect this by the inequality we use in the table. So notice we've got 130 still because we want the first row and the second row, so 130 to 150, which is the 4 plus the 11, which is 15. So our next height then, again we'll start with 130 because we want to accumulate them as we go through. So 130 to the 160 will be the 4 plus the 11 plus the 24, which will give us 39. In a similar way, we can get the others. So now we're adding in the 22 and then we're adding in the 19. If you check then the frequencies all added up to 80, and this is what the last cumulative frequency should be in your table. Here we have some data for Usain Bolt and other athletes. These are the 100 metre times at the 2012 London Olympics. So we have times ranging between 9.6 and 10.2 seconds. So they're greater than 9.6, not equal to. So there was 1 time between this interval, so the cumulative frequency for this will be 1. For the next cumulative frequency, we want the times between 9.6 and 9.9, so this will be the 1 plus 4, which is the 5. Then between 9.6 and 10.05, so this will be the 1 plus the 4 plus the 10. And then the last one, 9.6 to 10.2, which will be the 1 plus the 4 plus the 10 plus the 17. Now, to save the hassle of having to write out a separate table, we can use the previous table but just add in this column called the cumulative frequency, CF. Now we've got to be able to plot and draw a cumulative frequency graph. So we're going to plot the data in this graph here. Notice along the bottom then, our time axis is a continuous scale and goes from 9.5 up to 10.3. The times only start at 9.6, but by starting at 9.5, I know I've got enough data and space on my graph. The cumulative frequency should go up to the final value that I need to plot. Now for a cumulative frequency graph, we always plot at the end of the interval. So last week's work, we looked at frequency polygons, where you plot in the middle of the group. Not for cumulative frequency, we plot at the end of the interval. So the first one, we are going to plot the cumulative frequency of 1 at 9.7. Now notice that they have plotted 0 at 9.6 because the smallest time we can have on here, although not strictly equal to it, is 9.6. We know there won't be a time before this, so that we can plot this as 0. But the most important thing to note is at 9.7 we plot the first cumulative frequency of 1. For the next one then, at 9.9 we will plot a cumulative frequency of 5. So that's here. At 10.05 we will plot a cumulative frequency of 15, that is here. And at 10.2 we will plot a cumulative frequency of 32. Now mark schemes allow either a curved line or joining each pair of points with a straight line. As you can see, Dr. Frost prefers the straight line. I generally use a curved line. It is entirely up to you. Questions we can be asked then about a cumulative frequency graph. We can easily find the median from a cumulative frequency graph. Now because there are 32 athletes within our table, the median will be the 16th. Now before, when we were looking at the median, we were adding 1 on to the data value. Now when we've got cumulative frequency graphs, we don't need to do that. We can simply just half the actual total to use the median. So to get the median then, what we do is half the 32, so the median will be located at the 16th value. So we draw across to our cumulative frequency graph and down and read off a value of 10.07 seconds. The lower quartile, remember, is 25% of the way. So 25% or a quarter of 32 is 8. So we read across from 8, we draw a line, really important you draw lines on your graph, across to the cumulative frequency curve or line and down. So the lower quartile is 9.95 seconds. The upper quartile is 3/4 of the way up the data, so 3/4 of 32 is 24. So reading across your graph and down, the upper quartile is 10.13 seconds. So the 16, the 24 and the 8, remember, are not the median, the lower quartile and the upper quartile. It's the values that you read off down from your axis. What will the interquartile range be then? So remember, the interquartile range is the upper quartile, take away the lower quartile. It's how spread out this middle 50% of the data is. So the interquartile range here will be 0.18 seconds. We can also use a cumulative frequency graph to answer different estimation questions. Let's have a look at these. Estimate how many runners had a time less than 10.15 seconds. So 10.15 seconds is here. This time we're going to draw a line up to our cumulative frequency curve and across. So if we do that, 26 runners had an estimated time of less than 10.15 seconds. Remember, these times can only be estimates because the data was grouped to start with. Next one, estimate how many runners had a time more than 9.95. So this time we're going to go to 9.95 and read across. Really important, this question, as it says more than. Because when we read off from 9.95, yes, that is 8 runners, but we wanted more than. So we have to subtract this from the 32. So 24 runners had a time more than 9.95. 8 runners had a time less than. Last one, estimate how many runners had a time between 9.8 seconds and 10 seconds. So this would require us reading the values off for 9.8 and for 10. And you should find that they're 11 subtract 3, which gives us 8 runners. So how does this compare then to the work we were doing last week? So last week you were looking at drawing frequency polygons. If you haven't managed to complete the Hegarty clip on this, please go back and have a go at it. So let's plot this graph here. Let's plot the data again. So plotting the first value, remember at the end of the interval for cumulative frequency we would plot the 1, whereas for a frequency polygon we plot in the middle value. So we plot at 9.65. For the next value, so for the cumulative frequency at 9.9 we plot 5, but for a frequency polygon we'd plot at 9.8, we plot in the middle of the value and we just plot the frequency, which is 4. For the next value then, so again for cumulative frequency at the end of the interval you are plotting the cumulative frequency total, but for a frequency polygon you are plotting in the midpoint of the data just the frequency. And for the last one again, for cumulative frequency at the end of the interval you are plotting the cumulative frequency, whereas for a frequency polygon you are plotting at the mid value and the frequency. So if we sketch in the cumulative frequency and the frequency polygon, generally a frequency polygon will vary with the frequencies. A cumulative frequency graph will always continue to increase because you are accumulating the totals as you go along. This is a common mistake in GCSE exams. So many times students will draw a frequency polygon instead of a cumulative frequency graph. So know the difference between the two. I've chosen this. This is from the Dr. Frost PowerPoint. You can pause the PowerPoint now and have a go at these, but there are the other exercises as usual on the system. It's entirely up to you which questions you want to choose to do. If you pause the video, you could have a go at these. So I'm about to reveal the answers. A textbook example then, just to go over and consolidate what we've done. Here we've got a table showing the marks of 100 students in an English exam. So we have the marks, we have the number of students or the frequency, and then the cumulative frequency has been completed for you. You're asked to draw a cumulative frequency graph. You are asked to use the graph to find the median and the interquartile range. You are then asked to use it to estimate students that need to resit the exam, if they've got to resit, if they get less than 44. So this is what the graph would look like. Remember, at the end of the interval you are plotting the cumulative frequency. There were 100 students, so this is where our cumulative frequency curve should end. Be aware, sometimes in GCSE exams they will take the scale higher than is actually needed. So if our scale in an exam had gone up to 120, we do not go to 60 to find the median. We always look and see what is the last cumulative frequency value plotted, and it was 100. So we're going to read off the median at the 50 mark. We're going to read off the lower quartile at 25, as it's a quarter of the way, and the upper quartile at 75. So the median mark is 65, reading off, the lower quartile is 51, and the upper quartile is 79. Remember, the interquartile range is the upper quartile, subtract the lower quartile. It is the spread, the width of the middle 50% of the data. To estimate anyone resitting, so they resit if they get a mark less than 44, so they go to 44, they draw up to the cumulative frequency and read across, and they estimate that it will be 17 students. Remember, it's only an estimate because the data to start with was grouped. Hints and tips: the median is often abbreviated to M or Q2. You will certainly see this in A-level textbooks if you go on to study maths and further. Also, the upper quartile we abbreviate to Q1, and the lower quartile we abbreviate to Q1, and the upper quartile to Q3. The interquartile range you will sometimes see as abbreviated to IQR. Now I've put a couple of questions from exercise 18C that I think you could have a go at. The whole exercise for 18C is in the folder, so it's entirely up to you and what time you have. So here is question 1. You could pause the video, copy out the table and have a go at drawing the graph. Here is the solution for you to check. I've then selected question 6, which is the interpretation of a cumulative frequency graph. So pause while you have a go. There's the answers for you to check. Now, if you complete Hegarty tasks 437, 438 and 439, they will consolidate your understanding of cumulative frequency. I hope this has helped and good luck.